We are a class at the school GRG19 in Beirut Street 73, Vienna, Austria. Our study analyzes Austria's carbon dioxide and methane emissions, the effects of climate change on tourism and biodiversity, and the long-term parameters of lakes in Austria. It offers insights into environmental challenges in Austria and proposes various mitigation strategies.
We have collected data on carbon dioxide levels in Linz and Burgenland using the European Space Agency's air quality platform from Vienna using a special measurement device placed at the top of our gymnasium, the GRG19 Bürgerstraße 73, Vienna, Austria. The data were available daily from 1st May 2022 to 28 February 2024. The CO2 measurements from Burgenland were stable over the years at around 270 ppm. The data from Vienna showed increases in the CO2 values in December 2022 until March 2023. The data from Linz varied substantially in the recent years with values ranging from 150 ppm to 2800 ppm. The curve fluctuated with highest values in September 2022 to March 2023 and from October 2023 to January 2024. The trend line here shows a strong correlation of lower temperature with higher CO2 concentrations. During colder times in Vienna, people tend to use more heating, which usually comes from burning fuels like coal or gas. This burning releases CO2 into the air, making the CO2 levels higher. Next, we looked at Austria's methane emissions using EU browser time-lapse. Austria has no methane emissions above the value of 1,600 ppm. However, surrounding Austria are visible methane clouds originating from the neighboring countries. These clouds represent elevated methane concentrations, underscoring the transboundary nature of methane emissions. Austria is primarily affected by the methane emissions of the neighboring regions rather than generating significant domestic emissions, indicating its role as a recipient rather than a producer of methane. Here we extracted a few images from the EU browser time-lapse and inserted the time-lapse too. We have created a video that shows the changes in the methane emissions in the neighboring countries.
Here you can currently see NOAA working on a time-lapse from Traunsee, including the years 2000 till the year 2024. The scene switches to Nico working with Excel and creating a statistic from Wörthersee that's illustrating the water temperature, only adding the month July from the years 1943 till the year 2022. This data was gathered from the hydrographic service Carinthia. The diagram that is shown here is our final product. Here you can see that the water temperature of the lake Wörthersee has increased over the last 2 decades and will most likely continue to rise in the coming years. First, we plotted the available water level data between the years 1941 and the year 2023 and estimated the red trend line. This step helped us to detect significant trends and patterns in the available data. The negative slope of the trend line indicates a declining water level. This trend can be attributed to climate change, as higher air temperatures tend to result in increased evaporation of the water. In this scatter plot, the y-axis represents the water level, and the x-axis the water temperature. The graph shows that the trend line has a negative angle, meaning that the two water parameters are related. In this statistic, the line indicates that a high temperature leads to a lower water level. The analysis of water temperature data reveals a positive trend, indicating a continuous increase in temperatures. This trend aligns with the clear impacts of climate change. The statistical evaluation of the data demonstrates significant deviations from historical average temperatures over the years.
The illustration shows Schladming and how it has changed from 1990 to 2018. Now we'll explain what the important colors stand for. The red color stands for discontinuous human fabric. The dark green color stands for coniferous forest. The light green stands for mixed forest. The pink area stands for sport and leisure facilities. As you can see in this illustration from 1990, the development is relatively small. Now we come to figure 2. As you can see here, development has increased significantly in the last 10 years, mainly due to sport and leisure facilities. Now we come to the next figure. This figure shows how much development in the north has changed. You can see that a lot has been added over the years and that it will continue to get worse in the future.
Our school, the School in Green, is dedicated to creating a greener environment. We've implemented various initiatives like our GRG-19 space team, working with the European Space Agency, but also interdisciplinary projects on ecology, climate and space, and improvements like recycling, solar panels and reducing plastic waste. We've also maintained areas in our garden for insects and plants, run a beekeeping project, and have a weather station with data available on the school's website. These activities create awareness and act as multiplicators for future generations.